Okay, so far we up to this point on the normal, we've learned how to calculate z-scores. We've been able to figure out probabilities. We've learned about the empirical rule, and um, we can say that 95% of this stuff is below a certain amount, etc. But what happens if I want to find an interval centered about the mean, and I wanted to find the actual values centered about the mean? So I should have enough information to do that. So let's go back to the empirical rule. And remember that 68% are between plus or minus one standard deviation, and 95% are between plus or minus two, and 99.7 are plus or minus three. And you remember our z-score formula, z equals x minus mu. If I rearrange it, I could go x equals mu minus z times the standard deviation, or x equals mu plus z times the standard deviation. And basically all that said is, if this was one, could be a negative one z-score, and this could be a positive one z-score, and it would just give me this and so this time it might be helpful to know a lower value and an upper value in which we contain a certain amount of data. We know 68% is contained here, and we generally express it as plus or minus. We just use the plus or minus symbol, so that way we don't have to write this twice, right? And all we did was rearrange that through algebra. So going back to the previous problem on serial, we had a mean of 16.2. Well, plus or minus one standard deviation, our standard deviation in that case was 0.1. So this would be 16.3, and this would be 16.1. And this would be 16, and this would be 16.4. So between 16.0 and 16.4, we'd have 95% of our data. And if we went down to 15, this would be 15.9, and this would be 16.5. And between 15.9 and 16.5, we'd have 99.7% of our data. All right. So I can do that very easily with the, if I know the empirical rule. But sometimes I don't have nice even numbers. So let's use the empirical rule to determine how we might be able to do that. So what we could do is we can go 1 minus a percentage, which in this case would be 1 minus 0.68, and divide it by 2. If I did that, that would give me my lower value. For the upper value, it'd be 1 minus the percentage divided by 2, and then re-add the percent. So you're going to kind of need to make sure you know how to use this, and we're about to do it in just a second. Because basically all I did was go, all right, well, we did it here, but let's try those right here. We can use the empirical rule, but what if it were 80%? Well, I don't know my z-score off the top of my head for 80%. So here's what I would do. I would go something like this. My lower bound. So my lower, I go lower, okay. And by the way, this is not on the formula chart, is 1 minus 0.80 divided by 2. So that ends up being 0.20 divided by 2, so 10%. So that gives me my z-score that I need to find a z-score for that. So if I'm drawing a picture, what we're actually saying is this. This area right here is 0.80. And so this area right here is 0.10. And I need this z-score, and I need this z-score, and I'll need this x, and I'll need this x. And we know that we're centered at 16.2. Okay? So to get that z-score, and remember, z equals x minus mu over sigma. And we know we don't have the x, and we don't have the, we do have the mean of 16.2, and we have our standard deviation of 0.1. So if I go like this, second vars, inverse norm, and go, oh, we're looking for 10%, 0.10, mean is 16.2, our mean is 0, Standard deviation is 1. There's my z-score. My z-score is negative 1.28. And then we go to calculate it with the actual values, second vars, inverse norm, 0.1, mean of 16.2, standard deviation of 0.1, and we get our actual value and go, oh, 16.07 is right there. So 16.07 is my lower bound of that. Now I want to find the upper bound of the same thing. So I'm going to do the same thing that I have over here, except I have to add 10 plus 80. And that's what this said right here. I divided by 2 and got 10. Then I have to add the 80. So I need to do, this is basically 90%. So I got to do a z-score for 90. X minus mu, or X minus 16.1 over, or that's wrong, 16.2, excuse me. So 16.2 over 0.1. Second vars, inverse norm. My area is no longer 0.1 because it's the sum of these two, which is 0.9, 0, and 1. I get a z-score of 1.28, and that's not surprising because it should be symmetric. So I have 1.28. Now I can go calculate the actual value, second vars, inverse norm, and 0.9, oops, 0.9. My mean is 16.2, standard deviation 0.1. And I end up getting 16.328. Now I rounded and I didn't take it out enough decimal places. But if I did that, there should be 80% of the value should be in there. So let's try that out and see if we can't justify that. Let's go second vars, normal CDF. And we have 16.07. We should be close to 80, but I rounded 16.328, mean of 16.1, or mean of 16.2, and a standard deviation of 0.1. And we're pretty close to 80%. We're 80.2%. And that part that's off is due to my rounding things. Okay, so that was 80%. So now we ask you to do it for 98%. Well, at 98%, we know that we're at 16.1. This is 0.98. 1 minus 0.98 divided by 2 equals 0.01. So this is 0.01. All right. And I need to find this z and this z, this x and this x. And so z equals x minus mu over sigma. I keep putting that in the wrong spot. So minus 16.2. This is 0.1. We're looking for x. This is z. When I go about doing the lower side, second vars, inverse norm, and they ask for an area of 0.01. We end up getting 2.326. So 2.326 equals x minus 16.2 over 0.1. Second vars, inverse norm, and mean of 16.2, standard deviation 0.1. And I get 15.967. So this value right here, this x equals 15.9673. Now I need to do the upper side. Well, 0.01 to 0.98 tells me that I'm working with 99%. All right, that should have been a negative z-score. So because this is symmetric, my z-scores are going to be symmetric. So this is going to be 2.326 equals x minus 16.2 over 0.1. Second vars, inverse norm. And instead of 0.01, we're working with 0.99 because it's the sum of the 98 and the 1. $16.4326. All right, so I should be able to find the area between these two. So let's try that out by checking it out on norm CDF. So second vars, norm CDF, lower bound, 15.9673, upper bound, 16.4326. Mean happens to be 16.2, standard deviation is 0.1, and we should have about 98% of our data. That's really close to 98%. All right. All right, so last one, 99%. Well, we're doing this exactly the same approach. All right, we're centered on the mean. So this needs to be 0.99. Our mean is at 16.2. Standard deviation is still 0.1. I'm looking for this z and this x and this z and this x, right? And 1 minus 0.99 over 2, 1 minus 0.99 over 2 equals 0.005. And the reason I'm doing this is because people mess this decimal up. So this area right here is 0.005. So second vars, inverse norm, 0.005, mean is 0, standard deviation 1. So we have negative 2.57. So z equals x minus mu over sigma. So negative 2.57 equals x minus 16.2 over 0.1. At that point, I can come back and do the actual values. Second vars, inverse norm, 16.2, standard deviation, 0.1. And I end up getting an actual value of 15.9424. So x equals 15.9424. So that's my lower bound. My upper bound, we know we're just going to flip this, so because it's symmetric, so it's 2.57 equals x minus 16.2 over 0.1. Now I have to be careful. Second vars, second vars, obviously wasn't careful just then. Second vars, inverse norm. And what's my area? Well, my area is 0.99 plus the 0.05. So my area is going to be 0.995. My mean is going to be 16.2. And my standard deviation is going to be 0.1. We end up getting 16.4575. So x equals 16.4575. So this is my lower bound, this is my upper bound. Let's check it out to make sure that we have 99%, because we can do that using the norm CDF. So second vars, norm CDF, 15.9424, upper bound, 16.4575. Mean is 16.1, standard deviation, or mean is 16.2, excuse me, standard deviation of 0.1. And it should be about 99%. It's like 98999. Yeah, that's pretty close to 99%. Okay. All right. Hopefully that helps. Thank you.